So one of the ways that we're going to use algebra to be able to solve for similar triangles is if I have a similarity statement and I'm given some sides on that particular triangle, and then I have the other triangle, and notice it's not really drawn, like one might be flipped, it might be rotated. I can't rely on just left is the same as left, right is the same as right. So I have to rely on the similarity statement. So what that means is that I have to think to myself, I got to write a proportion. What does HG respond to in the other triangle? Well, that's DC. So I know that those are corresponding sides, which means when I write my proportion, that's what I'm going to use. Okay? Then I'm going to look at what else I'm given in the triangle. I'm given this BC. Well, BC corresponds to FG. Luckily, I'm also given FG. So I can finish my proportion. Okay? And we can go from there. That is one type of problem that you will see in this particular objective. Notice it says, solve algebraic problems using proportional parts. That's one of them, right? We have similar triangles. We're going to go ahead and write the proportion based on that. You guys know how to cross multiply from here. There are a couple of additional things that we can also write proportions from. And that's what we're going to spend the rest of class today talking about. So don't write this down. For right now, I just want you to look at it. Okay? And I'll tell you what the example is to copy in your notes in just a second. But another thing that divides things into proportional parts, not only are similar triangles, but angle bisectors do it as well. Notice angle bisectors are labeled with these little guys right here. We know what an angle bisector is. And what an angle bisector does is it divides these two sides, the sides where the angle bisector hits, and then it also divides them proportionally with the other two sides. I like to think left to right, left to right. That helps me for some reason. Sometimes the triangle will be rotated, but you can think about this is how you're going to set up the proportion, okay? So let's look at an example with numbers in it. Can we do that? And this is an example I want you to put in your notes. We'll call this example 1. Example 0 was that other one that we started with, okay? So you want to copy this one down. You have an angle bisector in a triangle, and it's going to divide the triangle into proportional parts. So, since I wrote the quiz for this particular section yesterday, I can tell you that the directions say, write the proportion and solve. It may or may not be multiple choice. Most of it's not, which means you're going to have to write the proportion. And that's where you're going to get some of the credit. Does that make sense? Okay? So, if you have highlighters or if you have colored pencils and you want to use those to label, that's great. But let's think about what corresponds. So I have these two sides, and then I would have the other two. And we're going to go left to right, and write the proportion. That's really it. So what is the proportion that I'm going to do here? X over what? What does X correspond to on the other part? X over 4 is equal to, since we started on the left, we're going to continue to start on the left. So I have X over 4, and then I have X plus 3 over, perfect. Okay? So how I set up the proportion is half the battle. Okay? Now we just need to cross multiply. We know how to do that. We did this at the beginning of class in our Kahoot. We went ahead and made sure that we were able to distribute where we needed to. Why am I putting parentheses around this? Carlo, why do I have to put parentheses there?
Because distribute.
I gotta distribute, right. And I'm going to distribute that 4 to both pieces. I have x's on both sides. Got to start moving stuff. What do you want to move? The 6 or the 4? The 4x, sure, that's a good idea. What does x equal? Good. Not bad? The proportion part shouldn't be the problem because we've been doing that for a while now. It's how do I set up the proportion that might give us a little trouble, okay? Or that's not trouble, that's just the new part, that's all. It's the new stuff. Any questions about how to do angle bisectors? Devin, you good? Okay. All right, let's look at, we're going to do 3 total examples, okay? Let's look at example 2. Now this one actually isn't really part of 5C as much as it's part of 5A. I want you to, it's kind of a combination. So let's look at the example first. Woo. Okay. So let's read it first. It's a pretty tough one. But I have to have faith in you. Notice I have a similarity statement. That is really important. If you are a color person like I am, I'm going to draw one triangle in one color and another triangle in another color. I'll do the small one in yellow, and I'll do the big one in green. Just so we have an idea, we have triangle ABD, which is our little triangle, and that's similar to the big triangle. That similarity statement is super duper important because it tells us what sides correspond to each other. Let's label what we know. We know that AD is 16, so I'm just going to label it such. We know that AC, which is this whole guy over here, is 31. And we know that DC is 23. So I'm just labeling what I know. We're trying to find the new perimeter, I'm sorry, not the new perimeter, but the perimeter of the little triangle. Perimeters have the same scale factor as the sides do. That's important information. I'm going to say it one more time. The perimeter has the same scale factor as the sides do. So let's write a proportion that relates those two things, the sides and the perimeters. This kind of goes back to what we did with that quiz, trade thing before break. So we're going to write a relationship between the sides and the perimeter. I have two triangles. I have, in my case, yellow and green, but let's call them small and large. So you might have different colors. And let's write a proportion to help us find the perimeter of ABD, which is the perimeter of the small one. This is what it's asking me for, right? Which is the X. Where does that go in my proportion? Top right, bottom left, where does it go? The perimeter of the smaller one. Bottom where? Bottom left. because it's the small triangle perimeter. So that's my x. So I need to fill in the rest of it with numbers that I can come up with. What other numbers can I fill in? Do I know the perimeter of the big one? I sure do. I just add them. The green triangle is my big triangle, right? Add up all the sides. That's the perimeter. What is 23 plus 31 plus 16? 70. Good, Halen. So I get 70. All right. Now I have to think about the sides for a minute. They have to correspond, don't they? On the small triangle, I'm only given one side. Do you agree? I'm given AD. AD is the only side I'm given. So let's put it in the small triangle. Or in that side of the proportion. Let's put 16 there. What number goes on the other side? It's not 16. What side in the large triangle corresponds to AD? AC. So what number would that be? 31. Are we okay with that? That kind of combines a little bit on what we did with the quiz, trade, and similarity statements, and solving proportions. So that one combines a lot of stuff. Tell me what you get when you cross multiply. 31x equals 16 times 70, which is, what'd you get? Perfect. Divided by 31. I think you get a decimal. Yeah, and that's okay to get a decimal. Okay? So this one just kind of combines a lot of the objectives. Okay so far? All right. Last example. You ready for the last one? Okay. I don't want you to write this part down. I just want you to look, and I'll tell you what example I want you to write down in your notes. So let's just watch what this is called. Okay? This is called the side splitter. And what the side splitter does is it takes a bunch of parallel lines with some transversals. Now, I could make these triangles if I wanted to, couldn't I? Just kind of extend them all the way up. They don't have to be triangles, but they can be. But it divides them into proportional parts. In other words, the left over the left is equal to the right over the right. That's all. Okay? Just kind of, it's similar to the angle bisector thing. Do you agree? Left over left, right over right. So here's the example. By the way, you have to have parallel lines. It doesn't work unless they're parallel. Okay? That's important. So let's look at this example. This is your example 3. Oh, not this one, sorry. This one, example 3. Go ahead and copy this guy into your notes. That perimeter one was example 2. Rather than write the words, I'm just going to label them right on the picture. I have parallel lines, so I have the side splitter, which tells me I can write them. I can write a proportion. And Ben, what's a proportion again? There you go, all right? Learned something today. Love it. So I want you to be able to write a proportion and solve. That's really all what 5C is. Write a proportion and solve. Write a proportion and solve. It gets a little repetitive. Lots of algebra. We're cross multiplying everywhere. I have parallel lines. So that means side splitter. What is the proportion? You'll need a minute to copy it. What is the proportion? 7 over 21 is equal to 6 over, there you go. Not meant to be hard. Okay. What does 7x equal? What is 21 times 6? I got 126, right? And that divided by 7, I think you get a decimal here again. Oh, it's just 18. Nice. All right. Before I give you your practice problems that I want you to work on independently, there's a problem that comes up that I want to talk to you about. Because I have a feeling that it's going to cause people some problems. So you have one that looks similar. Now don't copy this down. I just want, I'll leave this up on the board for you to kind of refer back to. But I want you to look at it. What makes this one different than the one we just did? I've got x's and y's, okay? So I have to be careful. I don't want to write one proportion with both variables. So how could we have to solve for both of them. Let's just first solve for x. What proportion would I write to solve for x? Well, look what you can do. I can cover up the middle. And if I cover up the middle, isn't it x over 4 is equal to x plus 2 over, that would work. Okay, that's fine. In other words, I can say this over this is equal to this over this. That will work. Okay? How about solving for y? This over this, doesn't it also equal this over that? If I wanted to, and that's the only way I could do to solve this actually. So I would have to say y minus 4 over 4 is equal to y over 3. Okay? All right. I'll leave this up here for you to refer to.